Hey, what's up? Welcome back to another Honkai Star Rail video on the stats section where we're looking deeper into the speed stat. Now, speed is kind of under the hood. It's not very clear what it exactly does, but as you get deeper and deeper into it, you realize more and more about how it is kind of governing the whole game. So let's take a look into it. But one of the most confusing parts is that there's a lot of speed terms. There's action, advance, turn, cycle, count, faster, slower. I'm going to break down these, and there's three main categories. The first one is your time component. This is a duration. Well, not technically a time in game. It's not a real time game. It does track how much amount you have left, and that amount is in action values or in cycles. These are the units of measure. So, common terms you would use is it's coming up sooner, later, he's going before or after for an order. So, during that time, you can take occurrences. Something happens. These are the actions you can take. So, you can engage them, you can attack them. So the common terms are you act, you move, you go, it's your turn. The conversion between how much time has elapsed and how many occurrences or attacks you can do is the speed component. And those are governed by going faster or slower than other units. So, understanding these three criteria of how they convert between each other and having precise language is key to understanding speed better. So, to understand speed, we are using the track model. If you consider that there's all these units, they're running around the track, an occurrence happens when a unit gets to cross that finish line, and then they get to go. And then the next unit gets to the finish line, and then they get to take their action. So you can imagine these units are all running around in a circle. Some are running faster than others. Some of them get to the finish line more often than not. But on the side, though, there is a guy with a clock, and he can predict out how long it takes each unit to get back to the finish line. That is the action value bar that we see on the side. And I've color coded them right next to the unit to figure out how many action values it takes for them to get to the finish line. So uh, between that, there's underlying within each unit. We see them all kind of moving around the track. They each have their own speed, and the individual speed is correlated with their own stats, but it doesn't immediately speak to how many action values are left. For example, the purple and the blue, although they're right next to each other in distance, the purple one is a little faster because it only has 40 action values to get to the finish line, while the light blue one requires 45. So, although they have the same distance to cover, the clock person will be able to distinguish the differences between them. And on the order, the purple would go first and then the light blue. So this model is key in understanding some of the changes that can happen with the speed, but we'll look into that later. First, we're going to figure out how speed works as a scaling method. If we consider the time between your turns, technically the period, uh, it's like asking how long does it take for a unit to run around in a lap? So the formula is it takes 10,000 and it divides it by your speed, and that is your turn time. So the standard measure is if you have 100 speed, it'll take you 100 action values, or one standard cycle to complete. Well, when we're trying to calculate damage, we want to know a little more than that. We want to figure out, hey, I have a period of time. How many actions can I perform? So, for convenience, I'll suppose that I have 10,000 action values of time. How many attacks can I do? Well, I take that time and divide it by how much time it takes between attacks. that time between attacks is actually just 10,000 divided by the speed. So the number of attacks you can do in 10,000 action values is actually just equivalent to the speed. So speed scales the number of attacks. So if you have more speed, you get to attack more often, and that gives you more damage output. It'll scale your energy gains because as you're doing more and more attacks, you get a faster rotation. Your energy stays the same. Your skill consumption is also at a constant rate because each time you go, you either generate or you use a skill point. So the unit's damage scales with the speed stat. This is a general rule for most DPS units. There are some disclaimers though. It is conditional on the unit's activity, what they do, not on the enemies. So, for example, dot units do not scale because the damage over time activates on the enemy turns. You cannot if you can trigger that on your turn, that can contribute to it. But natural ones that happen on the enemy turn cannot be accelerated using this method. Similarly, break units do not have as much impact with it because the break recovery time is dependent on the enemy's recovery time. The toughness shredding, though, is because that's the unit doing it. So more speed can increase toughness reduction, but recovering from that break is dependent on the enemy. Countering units require enemies to engage with them, so their damage output would not scale with their own speed because the damage actually comes from the enemy's aggression. And technically, there are some energy thresholds. If you are dependent on an enemy to hit you in order to meet your energy needs and rotations, if you go too fast, you won't give the enemy as much time to hit you. So you are more likely to actually miss your energy rotation to hit the ultimate if you are dependent on the enemy to hit you. So that is a couple of risks associated with it. But in general, you can use speed as a multiplier for your damage output. So the next thing we see is that, okay, if I just take our damage output and multiply by speed, that sounds kind of questionable. Why don't I just calculate the number of attacks within a time period? That's more fixed, more well known. It's not fair just to multiply by speed because that's comparing a continuous to a discrete amount. So why don't we just count how many attacks in the time period? Because the damage output is more like a step function, and if you're calculating speed, just multiplying it, it's more of a general slope. So in this graph, the actual output is in red. So at the beginning, you put out no damage, and then you take your turn, and then you shoot up, get some damage, and then you keep waiting for your turn again. Then you shoot up and do more damage. If you just multiply by the speed for your damage output, it assumes it to be this kind of flat, constantly increasing line. And there's a significant amount of error in between. While it is more accurate, actually, to do it in terms of calculating the exact number of attacks that happen within a period of time, in the long run, the approximation is much more valid because you have more attacks going through, and the percent error at the end of it is much closer. Additionally, you can't generalize it if you have different time limits as well, because you have to count each thing. If they have different HP amounts, it's also difficult to calculate because you're expecting your round to end within a certain period of time. And there are several battle conditions like slowdowns, crowd control, action advances from other units or other buffs. These can affect the number of turns your unit actually takes. For example, if they would have taken 5 but just so happened to get hit by a crowd control, now they suddenly take 4. If they had, suppose, some excess speed, they might actually still hold on to a 5 turn 5 actions that they can do in that period of time. And lastly, it's just easier to calculate multiplying by speed, because in the long run, you can analogize these discrete aspects into a continuous function. So, but the precise amount comes down to cycle counts. And cycle counts is really important because memory of chaos waves are measured in cycle counts. You know, the first cycle is 150 action values. Completing it in 90 gives you the same score as completing it in 70. And if each subsequent cycle is 100 action values, you know, it's no better to increase your speed if you just end up doing it within the cycle count anyways. So that's an aspect to min-maxing your units so that you don't spend an unnecessary amount. So this is where everyone talks about the 134 speed breakpoint. The reason why it's so useful and instrumental is because if you are at 134, your action value is less than 75 per turn. That means you can actually go twice within that first cycle. And if you have over 200, you can actually act 3 times. It's really useful because it's based on the amount of elapsed cycles. So if you act twice before the completion of the first cycle, you end up with a 0 cycle. And because memory of chaos does have aspects where it can have multiple waves, if they add together and one of them is just barely over, for example, you get a little over 5 cycles, well, maybe if you boost your speed a little bit, you'll actually get a little under 5 cycles, changing your count from a 5 cycle clear to 4 cycle clear, which could be really useful so that you can give yourself more freedom in the other round. So this is the main reason why precise speed tuning is really essential for the quick content. I would argue that due to highly volatile battle conditions later on, the speed advances, slowdowns from the enemies, it is much more difficult to predict out how many actions you can do in 5 cycles, 6 cycles. There is a lot more volatility around it. But in general, I would recommend optimizing within the first 2 cycles. I think that has much more reliability involved in it. But that's why the 134 breakpoint is so key. You can take 2 actions within the first cycle. So now we move on to the speed changes, the action value advances. These are all ways that you can move more often in it. So for the first one is a speed change. If you look at the track, the units are all running around. It's the same example as before, but there are a couple speed change sources, like Asta's ultimate, Seela's skill gives some speed, and Rodmay's passive gives some base speed. When you speed up a unit, it doesn't change how far away they are from the finish line, but it increases how quickly they get to the finish line. So if I were to give a speed bonus to the purple, and I doubled the speed, it went from 40 action values down to 20. It still has to cover the same distance, but it can move through that back period a lot faster. So after the green takes action, after only 5 action value points, the purple will take action. If you want to better optimize it, you have to understand that speed buffs are limited by turns, how long it takes to reach the finish line. So to maximize the amount of time the speed buff is active, you want to maximize the distance the unit has from getting to the finish line. So putting it on the purple, it reduced it by about 20 action values. But if you were to put it on the yellow, you would reduce it from 90 to 45. There's a longer distance of track it has before it actually gets to the start point to take action. technically, red is also included since it had just crossed the finish line and it has the most track before it comes around to another turn. Remember, reaching the finish line counts as when the buff ends, and if you receive the buff when it is currently your action, that actually does not count against you. So, uh, yellow and red are good options to put the speed buff on. There are some units that do team-wide speed buffs, and those will require prioritization. Not everybody's going to be at the end of the track with the most distance to cover. So you have to figure out which units you want to pull up, give more of an advantage at. It's going to come at the expense of some, but that's just part of what the speed tuning results in. So that's speed changes. The second one is action value advancements. They don't affect speed, but they affect distance. You want to consider it as like a shortcut, like you can cut across the track. So the yellow here, it's going to move with a 25% action value advance from the left part of the track into the right. It's still got a good amount of distance to cover, but it went from a 90 action value down to a 60. Its speed didn't change, but its distance did. And because of that, the timekeeper realizes that and says, okay, it only needs 60 to get there. So, various amounts of characters have action advances. Su Shang can do 15% of broken. Gwenifin has 25% at the start of battle. Numby is very keen on this because Numby gets a 50% follow-up hit if the follow-up hits the targeted enemy. So Numby will actually start kind of zipping around this track, always getting that 50 action value advances. Bronya, Jinglu, and Dan Heng inhibitor Lule, E2 of course, actually get 100% action value advance, so they immediately get to go. The win set can give some after the ultimate, as does Dance Dance Dance, the light cone, and multiplication after a basic attack. So there are all these ways that they can kind of jump around the track, and strategizing this is a part of the maximization. You don't want to overcap your action value advances. For example, the yellow, it still has a ways to go. But if you gave a 25% action value advance to the green, it's only going to get up to the finish line. It's not going to get any further. So because of that, a 25% action advance will not be as useful on it as compared to the yellow unit. Very commonly, Bronya does 100% action value advance, allowing them to go immediately. So if they are already about to go next, it's not beneficial to pull them up all the way to the front. It's most beneficial to pull up a unit who has just gone, and that comes to the -1 speed Bronya. But in general, you want to be keen on making sure your action value advances have the full capacity to be used. If it is overcapped, you won't get the full benefit, which is slightly suboptimal, but that is sometimes necessity is needed in these situations. So, final follow-up question. This has a list of questions to demonstrate full knowledge of what speed does, is like this. Let's say your DPS wants to do 3 attacks in the first cycle. First cycle having 150 action values. What speed is needed? Okay, if I have a support equipped with a S5 Dance Dance Dance, and they use it once during this first cycle, giving a 24% action advanced, its speed doesn't have to be as high, it's a little lower. So, what would that be? What if the support needs to actually basic attack before ulting, and then the ult has to be before the DPS? So, the support goes, does the ultimate, and then that pulls up the DPS a little bit. how much faster does that support need to be in order to have the ultimate active as compared to the DPS unit? So, understanding these questions will be a very practical demonstration that you understand the roles of speed and what can happen. So, make sure to like, comment, and subscribe for more Honkai Star Rail stats. Understand and explained. Make sure to follow for more, and we'll see you next time.